All right, so welcome to your 10.2 video in which I will finish off the worksheet about graphing parabolas. We need to fill in this box, and we also need to finish examples 5 and 6. So we're going to start with examples 5 and 6. And the issue with examples 5 and 6 as compared with 4 and 3 that I stupidly deleted, you should have notes on those. 3 and 4, if you notice, we don't have this middle x term. But in example 5 and 6, we do have a middle x term. And so here, the parabola looked something like this, but the axis of symmetry was still at x equals 0. Same thing here, it was like here, but our axis of symmetry was still at x equals 0. But as soon as I throw in this middle x term, that's going to cause my axis of symmetry to move. I'm actually going to be moving my parabola right and left. And that wreaks havoc with all sorts of things that I'll get into. But for right now, maybe just pull out your calculator. Let's actually put this in and just see what's going on. We'll look at the table and see what's going on with this, because I think looking at the table and the graph will help you to understand why we kind of need to mix up our method here. So first of all, take a look at this parabola. It definitely looks, I think you can see my cursor right now, it definitely looks like now the axis of symmetry is not going right through the y-axis. Maybe it's kind of off to the right a little bit. And so if in our table we only plug in -2, -1, 0, 1, and 2, this is no longer kind of capturing the middle of the function. Remember how we said that the values for -2 and 2 should be the same? Well, look at the table right here. There's 2, -1, but if we go to -2, oh, it's at 23. So -2 is at 23, but +2 is at -1. Why aren't these mirroring properly? And the reason they're not mirroring properly is because our vertex is no longer right along the y-axis. And so before I graph these and before I just start plugging random points in, I really need to find a method for the vertex. And we have a method to figure out where the vertex is now. The x-coordinate of that vertex is given by -b over 2a. It seems like kind of a random formula, -b over 2a. Now remember, I'm going to fill in the box up here. Remember that our general form said that a was in front of the x squared, b was in front of the x, and c was that constant term. And I'm now saying in order to find the x-coordinate of the vertex, do -b over 2a. So let's back in this problem identify what's our a, b, and c. Well, a is going to be 3. B is going to be -6, and C is going to be -1. So in order to find the x-coordinate of the vertex, I'm going to do -6, because B is -6, over 2 times A, which is 3. And this gives me +1. Yeah, if we simplify that, it's +1. So my vertex, the x-coordinate is 1. And take a look in the table here. Something is really interesting. Here's the x-coordinate of my vertex. What do we notice as I go to one point on either side? Here's where the mirroring has happened. So instead of just picking -2, -1, 0, 1, and 2, I'm going to pick points that are around 1. So 1, I can see, has a y-coordinate of -4, so that's my vertex. And then the mirroring comes from going 2 points below and 2 points above. And take a look at the y values. For 2, it's -1. For 3, it's 8. Then looking 2 down from the vertex, 0 is -1, -1 is 8. So we see that the mirroring isn't happening in exactly the same place, but there is still mirroring happening. So let's graph these points, and we'll see that my vertex is a little off center, but that it's still resulting in a nice mirrored function. Here we go. And again, try to make your parabola as U-shaped as possible. Yeah, that looks good. So what's my axis of symmetry, though? Remember that the axis of symmetry is no longer around 0. It's centering around the vertex. So my axis of symmetry, it goes right through the vertex, this is now no longer x equals 0, it's the vertical line x equals 1. Interesting. Domain is still all real numbers because it's always all real numbers. The range, well, it looks like I have a minimum point here of -4, and then the parabola goes up from there. So my range is y is greater than or equal to -4. Because again, -4 is my smallest point, and I'm going up from there. Now, how about the y-intercept? The y-intercept in all of our previous examples was the vertex. But where does it intersect the y-axis now? Well, I actually got lucky and had this point exactly graphed. The y-intercept happens to be -1. And there are two ways you can find the -1. First of all, we know that the y-intercept is always the point where the x is 0. So if I just plug 0 into the function, then I'll get -1. But let's see what happens when I actually do plug -1 into the function. Let's see. I have y equals, well, if I plug in 0 here, isn't that just going to be 0? Like 0 squared is 0, 3 times 0 is 0. If I plug in 0 here, isn't -6 times 0 still 0? So what's the only thing that I'm left with? -1. And this is the constant term. So as it turns out, the y-intercept should be c, and that is the constant term. And the reason is when I plug in an x of 0, all the other terms go away, except for the constant term. Pretty cool. So let's take a look at example number 6. Remember, I'm not just going to start barging in and making my table -2, -1, 0, 1, and 2. Because I can bet that since there is an x value in the middle, my vertex is not going to be 0. So don't make those points yet. Take them out. I need to use my formula. Remember, the formula for the x-coordinate of the vertex is -b over 2a. Okay, so b is 12, so -12. A is -2, so over 2 times -2. And if I simplify this, I have -12 on top, -4 on the bottom. That simplifies to 3. So in my table, the center point's going to be 3, and let's go 2 above that and 2 below that. And since I'm being a little lazy, let's just type our function into the calculator here. -2x squared plus 12x minus 9. Okay, so let's use the table to get these points. But remember, it's very important to go through the process of figuring out which x-coordinates to plug in. If you just look at the table, you might not get the vertex encapsulated in your points. So let's look at the vertex here. All right, 3 matches with 9. 2 and 4 are both 7. See, there's where the mirroring is. 1 is 1, as is 5. So I do have my mirroring. Looks like my vertex is 3, 9. Let's plot these points. It looks like this one is going to be a downward-facing parabola. I think I graphed that wrong. Downward-facing parabola, and we'll talk about how we can tell that in just a second. Okay, downward-facing parabola. Nice. So the axis of symmetry, remember, it's going right through the middle of the parabola, right through the vertex. The axis of symmetry in this case is right at 3. And how could I have known that? Well, what's the x-coordinate of the vertex? It's 3. What was the axis of symmetry up here? 1. What was the x-coordinate of the vertex? 1. So that's kind of a useful trick you can use. The domain, as always, is all real numbers. Range, since my highest point, since my maximum is 9, my vertex, my maximum is 9, the range, since the parabola goes down from there, is going to be less than or equal to 9. But what's the y-intercept? Remember, there are two ways that I can find the y-intercept. First of all, I can look in my table for the x of 0. Oh, look, it's -9. So I could actually also graph that point here. This parabola is going to continue going down like that. Or, remember, if I plug 0 in for x, these terms go away. What am I left with? -9. So the constant term is the y-intercept. All right, so we have just a couple minutes left in the video. Let's kind of fill in some of these gaps, some of the things that we found. Opening up or down? So let's see if we can figure out a pattern. Down here, this parabola is opening down. What do we notice about this function that might cause it to go down? This parabola is opening up. What do we notice about this function that might make it go up? And if you have your notes on you, you can also refer to these two examples and example 2. I think you'll find, looking at example 2, this was a downward facing one, that if it has a negative a value, like 2 and 6, this is what makes it open down. If it has a positive a value, like 5 and 4, then it opens up. So we can tell if it's opening up, the A is going to be positive. If it's opening down, the A is going to be negative. And remember, when I'm talking about A, I'm talking about this. Axis of symmetry, we talked about, is the same x-coordinate as the vertex. So x equals, I'll just put in parentheses, x-coordinate of vertex. The y-intercept, we said, was the constant term, or c. The domain we know is always all real numbers. The range, we know, depending on if it's up or down, it's going to, in some way, relate to the y-coordinate. So y, it's either going to be less than or greater than, and it's going to relate to the y-coordinate of the vertex. And these are things that you're used to. I'm just kind of summarizing them here for you, and it might actually make it more confusing. The minimum or the maximum? Well, remember, if the parabola is opening up, that's when we have the minimum. And when the parabola is opening down, that's when we have the maximum. And it also related to the y-coordinate of the vertex. Stretch or shrink, I think we'll ignore for now. Maybe I'll tell you about it in class, but let's ignore it for now. All right, so your graphing parabola education is done. On Tuesday in class, we'll be working on a worksheet on these, and then we have a partner quiz on Wednesday. You'll become experts. Just don't forget, for these trickier ones where I have a middle term, I need to use the formula negative b over 2a to find the x-coordinate of the vertex. All right, thanks for watching.